Okay, this is a demo of the RTFMv2 server. When I install the server, I'll have access to the driver. The driver is just an executable that will run on Windows, Linux, and BSD, and it'll allow me to run multiple instances of the server. So I can have an instance 1, 2, and 3. And within each instance, I have my own isolated database. So you can think of an instance, say, is for a red team, for a company. The red team will have different engagements as opposed to a penetration testing team or AppSec team, and they would have their own instance. And so the sessions that they do on maybe websites would be in here. For the red team, they would do an internal network assessment, malware assessment. That information would be here. And then all instances have access to the persistent database, which is just a collection of knowledge bases that a team can build and CVE data. So I'll show you the install process. And the install process is the same across the board. You click a few buttons and it's installed. It's very easy, whether it's on Windows, Linux, or BSD. Okay, so then we'll start the driver. We've got a default instance and a demo instance. And the demo instance has a different set of ports as the default as well. Also points to which database they'll be using. So we'll start the demo. All right, and this is the screen that you'll see when you first start an instance when there's no data. This will just collect or create seed data. And this is where we will set up our admin password. So we have default checklists, reverse shells, tools for Windows and Linux populated. All right, so up here it says that we have some settings that we can populate for AI and for our license file as well. And then we're taken to the sessions screen, which right now we have no sessions. We don't need a license file to interact with the server. So even if the license expires, we'll always have access to the data that we've created in our sessions. So any engagement we have, we'll always have access to it. But we can set up a license file here so that team members can download it. There's our license file. All right, so now that we've uploaded our license file, any team member can come in here, download the tools. So we have the RTFM Client, which is called graphical. We also, then we have the Linux and Windows versions, and then we also have the CLI as well. And then they can download the license to go with those programs as well. Now that we have our license file, let's set up our AI settings. So we're using AI for a few different areas right now. And one would be helping to fill in details for findings. We also have AI that we use for embeddings, and this is specifically for the knowledge base and CVE database. So whenever we download CVE data or we create a knowledge base, we create embeddings for semantic searches. And then also we use a different AI for evidence bags, and they can all point to the same provider and even the same model, although not for the embeddings, but they serve different purposes, so the options of using different models is there. So for demo purposes, I'll just use an Olama instance. Okay. And we can also, if we have multiple queries sent to, say, our findings, we want to populate description data, things of that nature for our findings, but this may take a little while. We can also add multiple endpoints and point to different providers as well, so that we send out one query, that query is working, and we want to send out another query. We don't need to wait for the first query to end. We can just send it out to a second or third endpoint. And this one is important. We'll need to specify a embedding model. Our options for our providers are going to be Olama, OpenAI, Anthropic, LLM Studio, Llama CPP, and a specialized agent framework. And we can talk about that later. Okay, so now that we have our license file set up, we have AI set up, let's create a session and we'll interact with that using the client. These fields are, of course, optional. It says optional, but it's also used for reporting purposes so that we know that this is for company A and the team that did it was the red team. These are just populated inside of a template for reporting purposes. We only have one user. Let's create a user real quick. Here we go. Now we have Bob. Let's go back into sessions. Let's edit the session. We'll give Bob access. Now we have a session ready. We have one host in this instance. So we'll go ahead and see what that looks like on the client side. Okay, so next we'll cover the RTFMv2 client. This is a graphical client. This is the workhorse for the entire tool set. It's a locally run application on your desktop, allows multiple users to collaborate and coordinate efforts on a single instance or an engagement, whether it's a red team engagement, a penetration test on a website. Helps for users not to step on each other's toes and redo work that's already been done, collaborate on information that's been gathered, log commands that's been ran, connect to remote terminals. We have integration with the RTFMv2 console that you can sit on edges of subnets and connect to those and run commands remotely. It takes notes, collects evidence for reporting purposes. We have built-in scanners for web, Active Directory, and other services, and overall helps collaborate, research information that's been gathered. So we'll install a new instance of that. This is the server that we had just set up. So we'll go ahead and log in. There's our session. First we'll go to downloads. We'll download the license. All right. And then since we're on Linux, we can do the console version, but This time we'll do the graphical version. And if I'm admin, I have the option of uploading a new version of it. If there's any quick fixes or anything that needs to be done, we can upload a new version. Other users will just have this download option. Okay, so we have our license and we have the RTFM graphical tool. And this relies on .NET, but it's self-contained. It's a self-contained binary. So if I don't have the .NET 8 binaries, it installs it for us because we've used apt install reinstall. So reinstall will just reinstall over any older versions if there was ever one. The only thing that we need to do, that's installed now. The only thing we have to do to start it is just RTFM. Okay, so now that we have the client installed, let's see what we can do with this. We have an option of doing a local session, which is disconnected from the server. This will not save data to the server, but we already have a remote session ready. So let's do that. We will log in as Bob. Here's his password. Here's the server that we set up. So let's see what sessions we have available. Just this one so far. Okay, so on the left side are all the tools that are available with Kali by default. So we have different in-map scans that we can do. T-Shark for sniffing, TCP dump for sniffing, DNS tools, and some web tools. These are categorized as remote enumeration tools. We have web-specific tools that we can run, like Derby and GoBuster. And then some exploit tools. And this is just within an attack flow. So mostly the flow of what you would do as far as enumeration goes, you normally do like a scan, a TCP dump, do DNS lookups. This can be changed. This is customizable. These are all the tools that are available, and these are categorized within the same category that Kali created. So enumeration, vulnerability scans, exploits, web, stress testing, forensics, wireless sniffing, password tools, things of that nature. So a lot of different tools that are available to the user. And we can just do a network scan. All right, and this is the output that we have with InMap. We'll see that the client actually is not up. So I brought the client up. We'll do this again. This time you see that it's discovered a number of different services. Okay, so that scan is a full scan. It takes a little while to perform, so I paused it, and we come back once the scan is done. It's found a number of things on the server. Now this is an in-map scan. This isn't a custom scanner that's being used, but once it's done, it collects the information in XML form and parses it. And once we parse it, it has meaningful information, so we can actually do something with this information. We can go to the host details tab, and we can see all the information that's been collected. So what version, what service is being ran, and we can interact with these services as well using different pieces like templates that have been added in the client. So for example, if we want to interact with the NFS service, We found in NFS. Let's go ahead and run a scan for that. And we'll come back once that's done. Okay, so the NFS scan is complete. This is the raw output that it finds. And then feedback on what was done and the information that was found. Now this will automatically sync every few minutes to the server, but we can also force a session update as well. So we just push that data to the server. So let's take a look and see what it looks like on the server. So here's our session, here's our target, and these are all the commands that were ran, and this can be used for reporting purposes, but we can get in here and see the output of each command as well. And then for reporting purposes, we can create a snapshot of this and put that into our report. There's our snapshot. That snapshot is also saved into our uploaded files as well. So the list of commands that we have, the AI output, which I'll cover shortly, we can look at what we're getting back from our AI since we set that up on the client as well. Just what it's found, some additional enumeration steps that we could take if we wanted to, if there's any known CVEs. The fact that this is a telnet session is a finding in itself. Let's see what else it's found. Every time it finds a service, it will query the database or query the AI and ask, okay, this is the service that we found, this is the information that we have, what are additional steps that we can do for enumeration, are there any known CVEs for it? And you'll get different responses based upon the different models that you pick. And this is just a local Quinn model. If we were to pipe this to a OpenAI or Anthropic model, you'll get a lot more useful information and probably get CVE data as well. Here's all the services that it picked up. Along with the host. We can look for our information based upon host as well, with the individual notes that Bob has put in here. This is automatically populated for our notes when we do like a templated attack. If there were other users that were doing this assessment, we would also have other users' notes in here as well. Here's some of the exports that, or one of the exports that found for the NFS scan. So as we continue enumerating data, it's going to save it into the server and we'll be able to collaborate more on this. We do have options on here as well as inputting this information into our report section, which we will talk about later. And as we enumerate more, there's going to be more tabs that you'll see that's viewable. So let's take a look at the AI options that we have for the client. So you see on the server, we set up our AI options in the admin panel. So we have for findings, embeddings, and evidence bags. It's similar for the client as well. If we go to session or file, AI settings, we have an AI model that we're pointing to. And we use this model to query whenever we find different events like services, for example. When we do an in-map scan, It collects the service, the port, any information it can, and sends it to the AI. This is the AI it's being used for. And that's also noted in the notifications up top. I'll show you that in a minute. But it takes time to enumerate all these different services. So there's going to be a backlog, and you'll see as you do a scan with multiple services, it won't necessarily keep up. It will eventually get through all the services and give you a reply back. But if you wanted to speed up the process, you could always add another endpoint here as well. Okay, so you can have a whole farm of AI providers, and it can use the same providers as the server as well. OpenAI, Llama, or Ollama, LM Studio, Llama C++. So those are just different options that you have. In the notifications, you'll see that these are populated whenever we do different events, like we collect information on services, and we can take a look and see what those look like. In this notification, you'll see it has collected some possible CVEs when it found a MySQL service, but this is also saved, and this is what we're viewing on the server as well. Let's start another template attack. So go to templates, and these are all through plugins, so we can easily add additional templated attacks. This is basically, if I find an FTP service, for example, this is what I would do for beginning steps of mostly enumeration. If I find a few things I'm aware of as far as an attack, I will go ahead and add that in to the template to see if it's vulnerable. But this is 99% enumeration, but a penetration test is mostly enumeration anyway. So as that goes, we'll take a look at some other things as well. We know that the service also has HTTP service. So let's look at the web agent. We'll use the option that we have, our provider that we've already had selected here. I know, for example, it runs a test vulnerable website, so we'll include that as our endpoint. We have known credentials, which is also very common in a penetration test to do further enumeration and evaluation of an internal website or the internal parts of the website that's protected. You'll often get credentials to test against. So we'll go ahead and use that in our scenario here. We'll test for SQL injection, LFI, cross-site scripting, parameter fuzzing, we'll go ahead and skip. We'll do file upload. We'll skip the scanner for now. We know that there's no subdomains. We'll just skip that. Authorization, we're already authorized, we don't need that. We'll do a GoBuster and Derby brute force. Password brute force, we don't need that, and we'll go ahead and generate a report. And this may take a little bit to finish as well, so we'll come back. Okay, so the web AI agent is finished. What this is working very closely with the AI that we've selected in the client, and it will have a AI manager. The AI manager works directly with the agent manager. The agent manager is mostly a router and data collector to what agent we're working with, which is, in this case, we specified the web UI agent. That specific agent only focuses on web UI, and that's it. And within that agent, it can assign different tasks. A task is defined within itself, it's self-contained, whether it succeeds or not. And a task can have one or multiple tools that it can utilize to finish the task. So within the task, then you have a child called a tool. And within that tool, it also works with AI to see, has this tool been successfully ran or not? And then once it believes it's been successfully ran or it couldn't run, it talks back to the task. And the task works with AI to see, okay, has this task been completed successfully or not? And it continues to work until it can or it has decided that it is not capable of performing this task, and then it reports back to the agent. So here's the log that we have, and it has these are different tasks in yellow, whether it succeeds or not. We have a link extractor for different links. We have GoBuster and Derby for different links and websites as well, or web pages within. So we will map the website using those tools. It examines the JavaScript as well. And we have automatic logging. Notice I didn't specify any login page or what parameters need to be modified to log in, because it works directly with Selenium and AI to log in using the credentials that I provided it. It comes up with a summary of the tools it ran, what it found, any findings. The cookie, in this case only one, this is the session cookie that was created once we did an automatic login. The headers that were collected, HTML that was collected and examined, any parameters that it found. We didn't do a subdomain attack. SQLi injection, LFI testing, we didn't do fuzzing. File upload, cross-site scripting, we didn't do a scanner, we didn't do auth testing. Overall evidence, and we also have a log as well, and we can see exactly what it did per page. Here we go. We also, for more sophisticated websites, when there's not just a plain older style username and password, if it has, say, SSO or MFA, we can use the manual proxy. This is a man-in-the-middle proxy that we can start. We can log in, it records it, and it takes every capture that we have, and you'll see a listing right here. You'll see a listing of all the pages that were captured, and we can say, okay, run a scan based upon those pages that we captured. Or we can say, use the session cookie that was created when we manually logged in, and log in yourself and do a scan as well. Okay. We'll go ahead and just push that to the server. We don't need to, but we'll do that so we can view and see what it looks like. So let's see what it looks like on the server. So now you see we have one entry. Before there was 0, but now we have one entry with the web agent. And it's a summary of everything. So this is the report, and it's a summary of everything that was collected, what was done, and if there's any findings. Along with the raw data as well. And any pieces of this we can add directly into an evidence bag or a narrative, and I'll show you what that is later. All the tools, everything that was ran is tracked and can be added into a appendix to the report as well. So all this information is saved a year from now when we come back and things have been updated to a website, or we want to test for something different that we didn't test last time. We have all this information, we have the appendix, so we'll be able to do a differential between the first test and this next test based upon perhaps new features that were added to the website. Also, if I wanted to assign tasks to different people, I can do that through here. Let's create another user. Pick someone with a smart name. This person sounds smart, so we're gonna make him an admin. And then we'll go ahead and add this one to our session. This person has access to this session. Let's go ahead and assign, this is added automatically. Let's break this up though. Investigate FTP. Here's our host. We can assign a specific host if we wanted to. That's fine. And we'll put this into progress. This will be progress as well. Okay, so we started the FTP template. This is the results. All the different commands that it ran. We can review this later. This will be uploaded to the server, and we also have the feedback as well. Okay, so let's take a look at what we found. We have very safe FTP 2.3.4, and we've already done a search for that automatically in search exploit, and there's 2 well-known backdoors for the specific version. So this is definitely a finding. So let's go ahead and create a finding for this. Okay, so we have a screenshot. Let's go ahead and we'll upload that screenshot. Let's make sure we've synced our data to the server, and we'll go ahead and see what that looks like on the server. Okay, back on our web server. Here's a screenshot that we added. Let's add this to our evidence bag. Evidence bag is basically a collection of information that we're going to use in order to create a finding. We can create a finding just by itself if we wanted to, but I found it more helpful to create it in an evidence bag. So within our evidence bag, it's just going to be a collection of commands and notes and things that we have found in order to create this finding. So we can add our initial in-map scan if we wanted to, because that found the service initially. Let's see if there's any other commands that we can run. Yeah, we can do a search exploit. See if there's anything else. Here's our FTP specific scan, so we'll definitely add that. And when we add commands, it automatically takes an image of the output. So there's our output, and it'll add it into our finding. The output also is included in the AI, so we can have AI help us generate information on it. But let's add a note to this. So we've collected everything we need for this finding. Let's go ahead and also select the image that we uploaded. And we'll add that too. Now that we have our evidence bag, there's a few things that I noticed. The output in our first command really isn't very helpful. So we're going to remove this. And it's the same with this, not too helpful. So we'll just remove that, because that will just create too much clutter and use up tokens with AI that we really don't need. Okay, now if you notice, the generate finding button is disabled. We need to check that we have a model that has image analysis enabled to it. And I'll show you what that means. If we go back to our AI options, we picked Quinn, which does not support imaging. So we're going to actually pick a different model that does. We'll just pick an open AI model. And we'll check this supports image analysis. We'll go back to our evidence bag. Now when we reload, we have this button available to us now. So this will take a little bit, but what it's doing is it's sending the images, it's sending the commands, the output, taking the notes, taking the title and description, put it into a bag, giving it to the AI, asking it, okay, give us some context to the evidence that we have here. And it's more of a scaffolding, a starting off point for our finding. So we found our finding, or here's our finding. Here's our title, high level. I would probably move that to critical. We have our description, our affected host. This is going to be rendered in HTML. Here's the impact to it, proof of concept. Pretty straightforward. In our recommendations and references. Now that we have a finding, let's go ahead and fill out a report, just an example report, and we'll see what the finding looks like in a report. So we have different sections here, and we can also pick a template, and we can pick out different options or sections that we want inside of the report as well. We can add our own custom section, and we can upload our own template and fill out that template with these keywords. So we see an start and end date is actually when we created the session. And then this would be a loop. So if we have multiple findings, this would be the finding row, like finding number 1, finding number 2, finding title, description. There you go. For now, we'll just set up a example report, and we'll use the AI assist for this. We can dictate, we can just talk to it, or we can just type in a request. Okay, so a penetration test on a single server with a vulnerable FTP server. Okay, so there's our executive summary. Again, we don't want to just generate this and send it off. This is meant to be reviewed and to be modified, but just a scaffolding or a starting off point. We can select so methodology is typically something that is boilerplate, and so in here we can create our own methodologies. Under the template, we can create a methodology. For now, we won't do that. Needs some formatting, needs some review, but again, just a starting off point. We'll review attack narrative later. The conclusion is best generated after we are sure we have all the findings in, because it will go back and review the findings and give a conclusion on those findings. In this case, we won't use the AI assist, we'll just use create conclusion. So this is a professional penetration test engagement. We identified a critical vulnerability in the form of an insecure FTP service. So again, it goes through the findings and creates a summary based upon that. The appendix is typically not used unless you want to generate the appendix from AI, some AI runs. I'll show that later on. We'll save this for now. Let's export. We'll just do, we'll do a PDF. So there's our executive summary, our methodology. We have one critical. There's the finding. And this format can change. This is just a generic format. All right, there you go. Now that we've shown an example report, let's create our boilerplate methodology. And there's different methodologies that can be used. Sometimes there's a methodology that's specifically for an external assessment, like a website assessment, a Wi-Fi assessment, internal Active Directory assessment, and you'll have different methodologies that you list on your report. This is our methodology. Single server. And we love the output so much, we're just going to reuse this. So there's our methodology. Go back in the report, and there it is, which is just the same. Okay, now some companies require an attack narrative, some do not. We can turn this on and off if we wanted to. And we also have a couple of options in order to help create the attack narrative. It's more of a scaffolding and a starting point for the attack narrative, not a end-to-end solution, because the attack narrative is, if it's included, a more meatier part of the report, a lot more descriptive and more time consuming. Now, this is AI driven. The AI that we're using is going to be a local AI, so it's going to take a while. I'm just using the Quinn model just for an example. So I'll go ahead and generate this. May take some time, so I'll come back when it's done. Okay, it's done. It took maybe 5 minutes with that Quinn model, although a normal penetration test would have a lot more commands, a lot more output, take a lot longer. but then you'd probably want to use a faster model like an OpenAI or Anthropic model. So it has a timeline, it has our commands, it has a summary of the output. So this would be an adequate start. A lot of this can be removed though. Okay, so that's one way to start an attack narrative. There's also a way to do an attack narrative builder, which we'll talk about next. So we go to narrative builder. Let's save this first so we can compare and contrast. Now let's go to the narrative builder. This is going to be very much like a evidence bag, but meant specifically to build a narrative. So we're going to list, there's a couple of other options here as well, but we're going to list the commands that we ran. And let's do this one. We're going to add that command. Full port, we'll do that one too. So this specific narrative is just a initial scan. So that's all we're going to do. We didn't find any users. We found a number of services though. I'm not going to list them all. Let's just pick a few. Okay. We can add any number of notes just like we can with the evidence bag. Now that we have the information for our initial scan, let's fill in some context with help with AI. And we'll see that our context might be too large. So let's go back into our AI options. It's under evidence bag. We have a max setting here, so let's just change this. Okay, let's see if we can send it now. Okay, now we've got the context back. So it took the logs and created its own context for you to start with. So it's not an end-to-end solution either, but it's a lot more descriptive, a lot more helpful. Let's go ahead and just add it to the report. Okay, so our attack narrative starts right here. Our attack narrative builder starts here. Here's our summary, adds the images for us. This is helpful. This I think I'll just go ahead and get rid of. So I'll have this image. And this is probably why we needed to up our tokens. Pretty sizable image. So there you go. We have a basic attack narrative that can be created, and then we have a more fuller, richer attack narrative that we can piece together, and we can actually order as well. So we can change the order of different attack narrative builders when we create more than one. We also have a lot of information that we collected from the web UI agent. Let's see what we can add to it, to the report, with the information that we've collected. Before we do that, let's go ahead and create another attack narrative builder. So have this, and we'll add a new findings evidence bag as well. Let's do so have that in there as well. We'll just use this as an example. We'll add that to our cross-site scripting evidence bag. Add that to our evidence. And we'll also add that to our narrative. We'll just add that both to the evidence and narrative. Then we'll also generate the appendix as well. So we've got one command and a couple of notes. We'll just say okay, there's our cross-site scripting finding. And we can also put this in our attack narrative so we know the timeline of when this was. Let's take a look at the attack narrative. Here we go. In the appendix. So there you go. More content for our report.